Chapter 6. Physical and Chemical Changes. You will learn physical and chemical changes, crystallization, reversible and irreversible changes, rusting of iron, galvanization. Every day a lot of changes occur around us. Iron objects rust, ice cubes melt into water, wet clay dries up, milk becomes sour, candles burn, chalk sticks get worn out, fruits rot, and so on. Changes occur around us regularly. Some changes occur very fast, such as breaking of glass, while the others are slow, such as change in the season. Among these changes, some are reversible, melting of ice, and some are irreversible, burning of paper. Most of the changes that occur around us can be classified into following categories. 1. Physical change. 2. Chemical change. Fascinating fact. Cut an apple and keep it open in the air for some time. You will observe that the color of the surface of the apple will change and become brownish. This is because the inner surface of the apple is now exposed to air, and this surface reacts with the oxygen. There are some of the reactions that show both physical and chemical changes present in the air. Water on heating vaporizes and on cooling turns into ice. This is a physical change. Water, when added to strong acids like sulfuric acid, produces a lot of heat. This is a chemical change. Physical change. Changes in which a substance undergoes a change in its physical properties like state, size, shape and color, etc. is called as physical change. The chemical composition remains the same. Physical changes involve the following properties. 1. Physical properties such as size, shape, color or state may undergo change. 2. No new substance is formed. 3. Physical changes are reversible, but some of them can be irreversible too. For example, cutting of cloth is physical change, but you cannot regain the cut piece of cloth in its original form. Changing of ice into water is a physical change. The molecules or particles in ice are strongly attached to each other. When heat is provided, the molecules of ice separate from each other and create more intermolecular space. With increase in their heat energy, the molecules move away from each other, and after a certain point, the ice ceases to solid form and changes into liquid, that is water. Thus, in this change, only the state changes, but the molecules remain the same. Hence, this is a physical change. Fascinating fact. Take a piece of paper and crumple it. You will observe that you have changed the shape of the substance, but not its chemical composition. Even if you cut a piece of paper into small pieces, it still remains a paper. Only the shape and size of the paper changes. There is no change in the texture or color of the paper. Chemical change. Chemical change is defined as the change which results in the formation of a new substance. It is also called as chemical reaction. Chemical changes are generally irreversible changes. For example, burning of paper, spoilage of food, cooking of food, digestion of food, photosynthesis, curdling of milk, ripening of fruit, rusting of iron are all irreversible changes. In a chemical change, a substance changes to form a new substance either by synthesis or by decomposing into two or more different substances. These chemical processes are called chemical reactions. Fascinating fact. Burning of firecrackers are based on the principle that chemical reaction gives out heat and light. For example, burning a sparkler is a chemical reaction in which heat and light are given out. Properties of chemical change. 1. Two or more substances react to form an entirely new product. 2. The properties of the new substance formed are different from those of the original reactants. 3. Chemical reactions are usually irreversible. The original substance cannot be recovered easily. 4. Most chemical reaction involves heat or light. Heat is either evolved or absorbed. Heat and light may be given out too. 5. Chemical reaction may result in color change or formation of a new substance with a different color. 6. Some chemical changes can result in formation of a new substance in the gaseous state. 7. Precipitates may form in some chemical reactions involving liquids. The new substance which forms may be in the form of an insoluble substance. This insoluble substance in the solution is called precipitate. The insoluble product or precipitate makes the solution cloudy before it settles at the bottom. In some chemical reaction, heat is produced, while in some reactions, heat is absorbed. Reaction in which heat is produced is called as exothermic reaction, while the reaction in which heat is absorbed is called endothermic reaction. Exo means given out, endo means taken in, thermic means related with heat. Displacement reaction. The reaction in which a more reactive element displaces a less reactive element from its compound is called displacement reaction. A plus BC gives B plus AC, where reactant A displaces B from compound BC and forms the compound AC. Rusting. Rusting of iron takes place only when both oxygen and water or water vapor is present. If any of these is not present, rusting will not occur. Rusting of iron. The rusting of iron is a chemical change. It is common to see iron rust and old iron gates, iron nails, iron pipes, steel furniture, old bridges, old car and truck bodies, iron shovels and spades. The reddish-brown coating of rust produced on the surface of iron objects is an oxide of iron. What is rust? The iron molecules of an iron object, which is exposed to air, combine with the atmospheric oxygen in the presence of water molecules and forms a new substance called iron oxide. This iron oxide is called rust. This is known as oxidation on iron. Rust weakens the bond of the molecules of the metal and thus makes the metallic object weak. Most of the metals combine with atmospheric oxygen to some extent and corrode except gold and platinum. They do not combine with oxygen of the air and retain their luster. Iron 4Fe plus oxygen 3O2 in the presence of moisture gives iron oxide 2Fe2O3. Causes of rust. 1. Iron can become rusted if left uncovered or without protection in the environment. 2. The process of rusting accelerates if the climate has lot of moisture in it. Rusting is an undesirable chemical change because it results in the formation of a compound which corrodes the metal and makes it weak. Fascinating fact. The iron pillar in the Qutub Minar complex in New Delhi is a classic example of production of high-quality iron. The pillar is said to be more than 1600 years old and stands about 6.7 meter high. The weight of the pillar is about 6,500 kilograms. Despite remaining exposed to the atmosphere for so long, the pillar has not yet rusted, which is an example of the high degree of accomplishment in the art of iron making by ancient Indian iron and steel. How to prevent rusting? Several methods by which rusting can be prevented are by painting. Paint contains oil in them, so the surface gets a thin protective layer on them to prevent them from getting corroded. By greasing. All the metals are painted or coated with oil or grease to save them from getting corroded. Alloying. Alloying means mixing homogeneously two or more metals. Example, stainless steel, an alloy of iron with nickel and chromium. Anodizing. In this method, artificial oxide layer of aluminum is coated on the surface. This prevents corrosion. Galvanization. It is the process of depositing thin layer of zinc metal, more reactive than iron, on the surface of iron. It is an effective method of protecting iron as zinc prevents rusting even if the surface is scratched. Fascinating fact. Along with iron, stainless steel contains at least 12% chromium that protects it from stains. The chromium in the steel combines with oxygen in the atmosphere to form a thin, invisible layer of chrome containing oxide, which acts as an effective barrier against rusting. Physical changes, chemical changes. 1. It is reversible. It is not reversible. 2. It involves change in texture, size, shape, etc. of the substance undergoing change. 2. Chemical changes. It involves change in chemical composition of the substance undergoing change. 3. No new substance is formed. Chemical changes. 3. New substances are formed. 4. No chemical reaction takes place. 4. Chemical reactions take place. 5. No energy is given out. 5. Light, heat and sound are given off as energy. 6. Arrangement of atoms remain same. 6. Atoms of substances are rearranged. Real life connect. Give each student 1 or 2 pieces of scrap paper, newsprint or pages from old magazines. Challenge them to work in groups to create as many physical changes of the paper as possible. They may tear, cut or color the piece of paper. They can crumble or even wet the paper too. Encourage students to be creative. Afterwards, let each group share a few of their examples with the whole class. Then challenge the groups to think of how paper can go through chemical changes. They do not have to carry out the changes, only list their ideas. Let them share these with the class. Some other examples of physical and chemical changes are as follows. Baking soda and vinegar. When baking soda and vinegar are combined, they go through a chemical change. Bubbles form because a gas is released, which is a new substance formed during the chemical change. In the kitchen, physical change or chemical change. When you chop vegetables, it is a physical change. When you cook them, are they going through chemical changes? Crystallization. Some substances occur in form of crystals. That means each of their particle has a very specific geometric shape. For example, crystal of sugar has the shape of a cube. Such substances can be obtained in their crystal form from their solution. This process of obtaining a substance in its pure crystal form from its solution is called crystallization. Crystallization refers to the formation of solid crystals from a homogeneous or uniform solution. Crystals are formed in many shapes such as cubic, tetragonal or triangular. For crystallization of a substance to occur, the solution must be supersaturated. Supersaturated means a state where so much of solute has been dissolved in the solvent that no more solute can be accommodated in it. Can you guess if crystallization is physical or chemical change and why? Fascinating fact. The bonding of hydrogen and oxygen to form water is explosive, and if the water molecules break apart every time water boils, life on Earth would not exist for very long. Most physical changes can be reversed. But chemical changes, but chemical changes cannot. Flame is affiliated with most chemical changes. You can have both a physical and chemical change at the same time. Chemical changes produce a new substance. Subject integration. The process of chemical changes is one of the part of digestion. During digestion, the food is broken down into very small and simple substance that cells of body can absorb. Body cells use the nutrients available in the body from chemical digestion to make energy. Skills and values. Students can understand the importance of the things, solid, liquid and gas around us. They can also understand their physical and chemical characteristics or properties. Rapid review. A physical change is a change that occurs in form of matter, but it does not cause change in its chemical composition. 2. A chemical change is a change where a substance changes to form a new substance. 3. The oxidation of the substance that takes place due to exposure of substance to the air and moisture is called as rust. Rust is corrosive. All metals except gold and platinum corrode to some extent. 4. Several methods by which rusting can be prevented are greasing, painting anodizing, and alloying. 5. Crystallization is a method of obtaining a substance in its pure crystal form from its solution. Key points. Physical changes, a change that occurs in physical form of matter but does not cause change in its chemical composition. Chemical change, a change where one kind of matter is changed to another kind of matter. Reversible change, a change in which we can get back the initial substance by reversing the action. Irreversible change, a change in which we cannot get back the initial substance by reversing the action. Oxidation, a chemical change in which a substance combines with oxygen chemically. Rusting, oxidation of iron resulting in formation of rust. Exothermic reaction, the reaction in which heat is produced. Endothermic reaction, the reaction in which heat is absorbed from the surrounding. Crystallization, it is a method of obtaining a substance in its pure crystal form from its solution. Reactant, a substance that undergoes a chemical change. Product, a new substance formed is in a chemical chain. Choose the correct